Kia ora, everyone. Chester Lampkin for Earth Sciences New Zealand. I am joined, as always, by John Tunster, meteorologist from both the Met Service and Earth Sciences New Zealand, and we're here to talk about the July and August, September climate outlook. John, good afternoon.
Good afternoon, Chester. Great to be back again.
Always a pleasure to have you, and you have a major contribution to this outlook, and so you're going to hear to kind of break it all down, but let's talk about the main story. It is El Nino, right, John? El Nino has arrived.
Yep, as long promised over the last several months and pretty much on schedule, we've declared that El Nino conditions have been met in both the ocean and the atmosphere in the tropical Pacific.
Exactly. It's a coupled system. You know, they worked in tandem. We'll talk more a little bit what we're seeing. But I want to mention that El Nino, which has officially arrived, it's officially official, leads to certain impacts. And one of the headlines is the dryness that we expect across parts of New Zealand. We've seen some hints of that already, maybe not necessarily connected to El Nino, maybe somewhat connected to El Nino, but we'll see that kind of get exacerbated over the next few months and through the spring and summer. But also, at least for the next 3 months, we're expecting pretty warm temperatures, too. So that's part of our headlines for the July, August, September time period, right, John? And so we've got that, and it's official. We can say El Nino has arrived. I'm not saying it's a good thing or it's a bad thing. It's just a thing, right? It's here.
Exactly. Yep. And what a huge turnaround we had. It was only 4 or so months ago, maybe 5, that the dial was all the way around the other side. Pretty unheard of switch around.
Incredible change in the ocean temperatures in the Nino region that we are concerned about, and incredible potential impacts too across the world, including here locally. So this is a look at the forecast for the next few months. This is what a lot of the people want to see. So let's kind of walk through the rainfall and the temperature forecast and how that may relate to the developing El Nino and other climate drivers, John.
Yeah, so if we look at temperature, as we were discussing before, it looks very bland. It's every area has the same most likely category, which is near or above average temperatures. I would say that the main tinge on this is coming from the extremely warm seas that are surrounding us.
Right.
It's less of a case that in some winters we see warm temperatures and it's because we expect persistent north or northeasterly flows. That's not so much the case this time around. It's more that we're just surrounded by these warm sea surface temperatures, as you're showing. And interestingly, these seas are warm at depth as well, which means that they'll be quite hard to erode away. And those will just provide this moderating impact on any wind flows that approach us. It doesn't mean, of course, that we won't get occasional cold snaps. It's just a general, over a 90-day period, moderating influence.
So that's really interesting. So we've got the warmth in the forecast as well as the fact that, you know, we don't have a lot influencing our weather nearby other than the warmth that's in the oceans. But we also have a lot of other factors to deal with, like MJOs and things like that. So what do you see impacting our weather over the next few weeks, the first part of this climate outlook before we get to the rainfall?
Well, you're dead right. There is another wave in the tropics, which is the MJO, as you say, and that has been kicking off some activity. And basically, we think it's contributing to this pretty awkward low pressure system that we're expecting pretty much early next week.
Right.
And the tricky thing about that is that it's expected to bring rainfall to some areas which for the whole season, we're expecting to be generally dry. So it's weather going a little bit against the grain of the seasonal climate outlook. And that just demonstrates that we do still experience day-to-day weather against the backdrop of our climate patterns. And so you can see that eastern areas we're expecting normal or below for the period as a whole. That's because we expect that as we get deeper and deeper into this outlook period, we should see eventually more westerlies than normal. Those tend to reduce rainfall in the east. And high pressure systems, when they do occur, especially as the season progresses, we think will sort of favor the North Tasman Sea, and so occasionally spread onto the North Island, keeping their rainfall subdued as well. Meanwhile, the area that stands out above all others is the western South Island, which, as these westerlies develop more, we'll see more fronts, we think, especially later in the period going into spring, and that should lead to a gradual uptick in their rainfall, hence the above average signal that we've got there.
I think it's a good point to remember then that exactly what you were saying and alluding to, that weather and climate, though related, aren't the same thing. We're still going to have weather. We're still going to get weather systems that could produce rain, like the one that is upcoming shortly after this video is released in the next week or so. But the long-term outlook, the average of all the weather is the climate, and that's where that dry forecast comes into play.
Exactly, yeah. And we also are in this, what we think of as a transition period at the moment, where El Nino's only just been declared. It's not really exerting its full force on us yet. And that ties in quite nicely to this. You're showing this is the forecast for El Nino going through pretty much to the end of the year. And what we're looking at here is the sea surface temperature anomalies in the Central Pacific, which is where we measure El Nino. And these are a whole bunch of model forecasts, and they're heading upwards repeatedly and persistently. And these models have actually been quite good over the last several months. So we do have reason to give them credibility. They've performed pretty well with the early stages of the El Nino, and no reason to cast major aspersions on their credibility at this stage.
Exactly. So we have a good idea of what is to come with the sea surface temperatures. And as we mentioned before, this is a coupled system where it has the sea surface temperatures have an impact on the atmosphere, and so we do expect impacts, sort of a knock-on effect. And we actually have a great El Nino video that kind of explains all the things that you deal with El Nino on our Niña page. So I would suggest, if you're curious about that, check that out. I'll try to get Stu to sort of put the link in the comments, and we talk about how El Nino can impact us, how it forms, the weakening of the trade winds, the sea surface temperatures, how that all interacts. We don't have time to explain that in the video, but I do want to sort of focus in on how the impacts or how it's going to impact us as we head not just through the next few months, but into spring, because our outlook starts to touch into the spring time period going all the way to September. So let's talk about the spring impacts just a little bit, John.
Yeah, so as we saw from the previous graph, this El Nino event is on an upwards trend, not expected to peak until late spring, possibly early summer. And what we do tend to see in historical strong El Nino events in spring is these kind of impacts that we've got up on the infographic, which is, this is a new chart that we've created. Very nice work from Hillary there. And we're basically trying to pinpoint the most impactful types of weather that we think will be more prevalent during the spring period. And generally speaking, we're looking at reduced rainfall in eastern and northern areas, periods of high temperatures, especially if you're east of the mountains, in both, say, Hawke's Bay, Canterbury, and increased winds in those areas as well. So in these particular northern and eastern areas, that all couples together to an increase in wildfire risk, because you basically have all these different factors compounding on top of each other, all of which contribute in their own way to fire risks. Elsewhere in the country, we think increased winds from the west, southwest, occasionally northwest, will be kind of a factor for the majority of the country. And meanwhile, in Southland, maybe parts of Western Otago and certainly Southwestland, we're looking at probably increase in rainfall throughout the spring period.
So, John, you've nicely explained the spring impacts. We don't have the summer impacts here just yet, but does spring and summer look much different as we head into this stronger El Nino, when, El Nino is expected to peak probably like late spring, early summer, but the impacts will continue for months on end from there?
Exactly. Generally speaking, early indications are that no, summer looks more like just a continuation of spring. I will say that when we're doing these investigations, we do like to look at, so we'll see in an upcoming graph that we've been looking at our 5 siblings of past historic strong El Niños.
Right.
We can extract common patterns from that family of strong El Niños, but they do have variation amongst them as well. And so, as an example, just to show that there are still curveballs amongst this.
Oh yeah.
Plenty of curveballs. The El Nino of 2015, 2016 did lead to a change of weather patterns early in 2016, which did go sort of persistently against the grain of classic typical El Niños. It ended up being much more humid. There were more northeasterlies. There was actually a reduction in westerlies. Now, that doesn't mean that we should expect exactly the same thing to happen again, but it is basically just a good reminder to us that El Niños don't necessarily lead to monolithic weather. Other things can sometimes nudge in edgeways, but over this long period of time, 6 to 9 months, we can extract sort of general prevalent patterns that are more likely than not.
So sort of recapping things before we kind of get super nerdy, because I want to get back to some of these really cool graphics that we have. This, for example, this the RONI here, the Relative Oceanic Niño Index, talking more about the sea surface temperatures. I kind of want to talk a little bit more about that. But before we get to that, I do want to kind of go back to the impacts for the next 3 months. If you are a farmer, if you have a garden, if you are someone who has interest in the water industries, and you're looking at this would give me some worries, wouldn't you think, like with the dry forecast for much of the country and the above average temperatures as well?
Yeah, exactly. I mean, what we're looking at here is a forecast of rainfall for a large part of the country that's either normal or below. Now, that kind of gives you the flavor, but it doesn't give you the extremity. So we want to be responsible and careful in what we're saying, where we're not sort of promising that the whole country is going to be covered with sort of earth-cracking droughts, that kind of thing. There's once you're into this sort of normal or below average rainfall, there's actually a whole variety of options within there. And we see this when we look through the past events. Generally speaking, for example, a great example, I've been looking at Canterbury recently. Strong El Niños for them in spring tend to have a dry flavor, but there's a whole variety of dry. Some extremely dry, some just a little bit dry.
Sure.
So it gives you a good indication, but it doesn't tell you just how extreme it's going to be. But with that in mind, if you're sensitive to water, I think you'll have some idea of, if the general expectation is you're going to have a rainfall deficit, you'll know what you need to do to start preparing for that.
Right. It's good to plan for the worst, but there is some cause for optimism. Past El Niños, as you mentioned, has had wet periods, and our forecast is not straight up below for Canterbury, Otago, or the Upper South Island, even the East or the North Island, but the forecast has a little bit of a wet lean, so there could be near normal precipitation. There may even be some areas that could be wet and others could be dry, and it averages out to be dry.
Yeah, exactly.
Yeah. Okay. With that said, let's kind of move on to sort of the nerd stuff. Let's get to the sea surface temperatures. And this area, this 3.4 region, is what we monitor in order to determine that El Niño has officially arrived. And so what does that mean? Like what is that threshold that we use here at Earth Sciences New Zealand to say, hey, El Niño has arrived because of this, this, and this? We'll talk about that, SOY, things like that. But what are those thresholds?
So when we look at sea surface temperatures these days, we have to adjust for the fact that the global tropical oceans are warmer than normal.
Right.
So what we're actually looking at here is a raw temperature anomaly, shows the same kind of pattern, but we're actually using our thresholds, which are now slightly tweaked relative to the global tropical oceans. Now, we've just exceeded, in the measures that we use now, we've exceeded a nice round number, which is a +1 degree anomaly in this box here. Once you get to +5 degrees, you're in +1.5 degrees.
Yeah.
You're into the strong category.
Right.
And our expectation is that we are heading that way within this outlook period. And as we've seen earlier, that's not the end of it. It'll strengthen further beyond that, most likely.
Right.
And this is why we're interested in these particularly strong historic events, which went above 2 degrees.
Yeah, in fact, if we may, let's detour just a bit. We're going to go back in time and look back at those past July, August, September periods during those El Niños, and we're looking back to what we call a composite. Explain to me and to the viewers out there, what does this mean when we're looking at a rainfall composite for those past El Niños for July, August, September? What does this mean?
So what we do is we bundle up actual observations from these 5 years that we've got listed here, and then we put them all together and see what's the anomaly that comes out from treating those years as a family of its own.
Right.
So it allows us to see patterns that exist across the entire family of strong El Niños. It sort of smudges out any of the inter-sibling rivalries that we see, the little quirks that are within given events.
Right.
But it does help us see common patterns, and it's a pretty strong common pattern where we have basically dryness in the east and for much of the North Island, and the west of the South Island, and the lower South Island looks wetter than normal. Now, it's not a million miles away from our seasonal climate outlook for this same period, but because we don't just take El Nino into account, we take other factors into account. This should not be used as a forecast because this only knows about one factor. And basically, some of these other factors are the reasons why we have not quite such an extreme dry tinge for eastern areas as would be indicated by this. We have to take other things into account, and one of those is that low pressure system coming up in early next week.
Yeah, exactly. We use weather prediction in addition to looking at the past. You can't know where you're going without looking at the past, but looking at the past is not a forecast. You can't always say, just because this happened, this is going to happen. But it gives you an idea, and I think that's what we've done such a good job of, is sort of using the past to ground ourselves, and then being able to say, okay, the computer modeling is saying this, the past has indicated this, and then making that forecast going forward.
Exactly, and we are in a tricky area because we are surrounded by seas that are much warmer than they were in any of these historical events.
Sure.
So there's a quirk of this current event right there. And what happens if we end up with the actual event becoming stronger than all of those as well? That's another potential quirk. So yeah, we can't just use history to guide us. But temperatures, again, now this kind of closely resembles, especially for the North Island, our seasonal climate outlook temperature categories. So we won't focus on that because it's warm in the outlook and it's warm in this composite. South Island is a little bit different, and people might think, well, why have you gone near to above average if the history says cooler? Well, we did have to adapt because of these persistent and significant warm waters that are surrounding us. And we've already seen in recent months that those have been skewing our temperatures warmer. May was warm, June was exceptionally warm.
Indeed.
And we're not expecting those warm seas to go away. So this is why our outlook looks warmer than this. Now, it doesn't mean we won't get cold outbreaks. We still have weather.
Right.
But we're talking about a whole 3-month period on average when we're doing the seasonal climate outlook.
Yeah, I think that's a great point because people will look at this graphic and, yeah, like you said, oh, well, 1997, 2015, if you look at all the past years, but we're not in the same world that we were then. Even just the 11 years ago since the 2015 El Nino, the world has changed. The sea surface temperatures are exceptionally warm everywhere, but they're very warm around New Zealand.
Exactly. Yeah.
Yeah. Okay. What other nerd stuff can we get to? Let's go let's go back. We didn't get to talk about SOI, but that's one of the things that we use to determine El Nino. So we talked about the Niño 3.4 region and those warmer temperatures. What about the SOI? What is it about this image that says, hey, this screams to you El Nino?
It's pretty amazing. It just looks like a squiggly line that's dropped off. It looks like your stocks aren't doing so well, perhaps. So basically, the SOI is one of these classic, really, really old measures. It measures the pressure difference between Darwin and Tahiti. It does some other statistics as well, but generally speaking, that's what it does. And this chart is beautiful. It shows that. Now, it's useful because it's very old. It goes back a long way in time. And it shows basically the atmospheric component of El Nino Southern Oscillation, which is what is happening to what we call the trade winds, which are these easterly winds that usually blow in the Pacific.
Right.
And what's happened, and what this chart is showing, and this beautiful, colorful image is showing, is that the pressures have changed completely and very quickly across Darwin and Tahiti. Normally what you have is higher pressures relatively sitting near Tahiti and lower pressures near Darwin. That gives you an easterly flow, but it's pretty much flipped. And so we have higher than normal pressures near Darwin and lower than normal pressures near Tahiti. That's what the Southern Oscillation Index is measuring. And when it goes as sharply negative as what it's done there, that's what it's telling us. So it's telling us that the atmospheric part of El Nino has really kicked into gear.
Right. So we have the atmospheric part. We have the ocean part. We talked a little bit about those sea surface temperatures, but I do want to show one more really cool image, and that is the subsurface temperatures along the equator. Let's walk through this before we wrap up here, John, because this is such an important part of what we were talking about. Because it's the ocean and the atmosphere. They have to work together for an El Nino or a La Niña to develop. So what's going on here?
So we're looking in the equatorial Pacific Ocean. So left to right along the bottom is west to east. And we're looking at the basically 300 meters below the surface. So at the top of the graph is the ocean surface, and at the bottom is 300 meters below. Warm colors are warmer than normal waters, and blue colors are cooler than normal waters. What we're doing here is we're tracking the warm waters that pushed across the subsurface of the Pacific Ocean starting at the beginning of this year. And this is what we've been watching for the last 6 months.
Right.
And basically, they're very slowly, these things tend to happen over the course of months. We're watching this warm water slosh from the west towards the east beneath the surface, and then start rising up as it reaches the eastern Pacific. And eventually it starts to reach the surface in the central Pacific, and it comes in from all directions. There's various driving forces that are causing that to happen. But you can kind of see in this video that warm water was there all along.
Right.
It's just it was below the surface, and it just takes a very long time for it to track across. And then basically these oceanic waves take care of things, and we recognize this as being a precursor for potential El Nino, and it turned out that it most certainly was.
Yeah, it's incredible to watch that water just kind of move from west to east. I think a lot of people don't really think about how the ocean is not static. They just assume it's warm near the equator, it's warm in the tropic, it's colder in the mid-latitudes, and it's freezing in the poles. But the water moves back and forth. It moves up and down vertically as well through the depth of the ocean. And all of that, before I got into any kind of subseasonal forecasting, I was not cognizant of the fact that this sort of action happened. And now we're seeing that, and that has such a major impact on the global climate. We're seeing heat waves in parts of North America and Europe, and undoubtedly there's probably some connection to those warm ocean waters and those heat waves.
Exactly. I mean, this video that we've been watching, and even the surface temperatures that we're back onto now, it is worth sometimes just sitting back and realizing that you're watching history in the making.
Right.
You can forecast for a long time and not see anything like this, and we're still just beginning.
It's incredible. So we've got several more months of El Nino to come, if you will. Is there anything you want to leave our viewers with before we close out for the day, Mr. Tunster?
I would say that our current seasonal climate outlook is covering July to September. don't expect that these westerlies are just going to switch on as of today, the 2nd of July, and persist for the entire 3-month period. We're on this journey. If we aren't there by September, it's going to happen most likely during spring. So don't let your guard down for El Nino impacts. If they're likely to affect you, be aware that this is kind of a long game.